Okay, in this video, I will first ask you to please comment below. Appreciate the support there. And let's try to help. Um, I'm trying to get you to see that these failed simultaneously. This butterfly effect. And and that's because we don't see a separation of the two decks. We don't see this broken and then this laying on top of this one. We see as if the planners failed also with this deck. With that said, we have to tie in the witness statement that he saw the cars go down first and then the deck. We put him at the observation point here. And what he sees is that the cars are going down, not realizing he sees the deck go down also at the same time because these are larger cars. They're standing up higher. They're going out of his view. They present more aggressively than a flat deck disappearing. So he sees the cars going down. The cars come to a stop. As you can see, they're on an angle, or probably on top of other cars. They would have kept going had there been no cars below them. I believe the cars below them, they would continue going down. But they appear to have stopped, and they're on an angle. But the deck to the right here appears to have, less cars, or cars are parked way back here. And so it appears to still keep going in his opinion. The deck punching shear going back to the structure are stopped by the cars that are right about thereabouts here, but not here. I think this is where the driveway goes across. Something about here is where the driveway is, right? So it takes that pull and tug over there, and, but we see the. I'm trying to zoom in. Great, I can't zoom in on this image anymore. So much for that. Well, just trying to get you in there and how you would see from his perspective how the cars would have been going down first, not realizing the deck is also sinking at the same time. The cars would come to a stop first in his visual effect, his visual. But the deck would have still been going down further at a plane. Now, like I said, if NIST would have did calculations from the height of the deck to the top of the post here, we'd be able to see the profile, the draping effect of how the deck went up and down. But they didn't remove this off like an archaeological dig to try to determine all this. We would see that, why did this only go here? Maybe there's a car there. Why did this crease over uh, hold itself up? Maybe there's even taller cars over here, trucks. We don't know because they're not giving us that data. Over here, we see that the flap went the other direction. There's a flap here going the other direction. There's a flower pot system on the first floor. Under here, what kind of vehicles were over there? What kind of vehicles? They don't appear to be sharing that data with us either. I'm only going to be able to briefly talk about the jealous wall, the anchoring of the flower pot system into this wall. And that's because I'm arguing with Univision right now about copyrights onto that video. I did a video with the police cam stuff some time ago, and it looks like I gotta wait 48 hours, and then it might be as much as a month before I get around to that body cam video. It's very important that I look at this part, is what I wanted to see to get the story of how this punching shear happened over here. I have the story. I'm refining it for you, and it will be dealing with no more breadcrumbs. But I just hate other people taking my stuff, so I just can't say it. But I'm refining this for you on actually the mechanisms here that went south. I'm refining that, and then you got your path here. Again, the visual effect from him would have been the cars going down, and then like they're stopping, and then he would have said the deck cars fell first, and then the deck. In reality, I believe both fell first, but the car stopped first, and then he assumes The deck is now failing as his eyes still see the motion taking place. From his point of view, though, it doesn't go all the way back to where he is, so he says the pool deck area, not right underneath my feet, not right there. So we have this area here is our reported initial sinkhole by the lady up top here who made the phone call. So there's a sinkhole. That's when you guys start getting a hold of me and the sinkhole theory goes around. I look at it, I'm trying to find the sinkhole, and I'll say, oh, yeah, there's the sinkhole. And then I look over here in the image with the cell phone video, and cell phone video only. And I'm like, no, that's punch here. There is no sinkhole. And then I load the video up for you guys. So this is going to be kind of critical. We got weight of the building that's caused some rest of the collapse here. So whatever's back here, we won't be able to determine whether it was the columns that buckled because of the load of all the extra of the structure, or if they were shoved over because of the structure. So that one's going to be a tough one. But there is a H beam in here that we will discuss. And Jamie's doing a good job now. Jamie's finally using his coconut there. Thanks, Jamie. And let's see if I can get you on that page. Hopefully you'll load this page. I think I have to go to page 162. It's loading. Rawhide. Okay, here we go. All right. You take it off? All right, cool. Okay. That didn't work. I guess you didn't like the memory of it. What page is I don't know really what page it's on here over here. Page 5. We'll take this one. No, we won't. We kind of will. The page numbers staying the same even though I'm going through the pages. Because I'm magnifying great. I'm not hitting the pages. There we go. Come on. This is crazy. Stay on the same page and I'm putting the up arrow. Alright, forget it. You win. Page 12. Let's try that. See, I press enter. It can go to page. There we go. Page 16. I know. I need to go to page 5. I'm just looking at something here. I just want to show you how they go from page 13 to page 2. How they jump around. But this has a staggered column going on, and I'll do an overlay for you. It's page 3. That's page 5. Okay. So over here is that what people now are in the comments is calling an H beam. An H right here. And the current plane going over, and the current images, they shift over. Okay, you know what? Let me do this. Let me do this for you. A couple of people are supporting this Greg guy that I'm misunderstanding him. So let's just put Greg into the category over here. Now, Greg says, let's cut to the chase to what Greg says right here. I watch your videos to help you out. Okay, so that's Greg's intent. He watches the videos to help me out. But here's where Greg comments are. Let's address that real quickly so you guys don't get all protective or whatever it is for Greg. He says that the kind of clearly here, 1'6" change wasn't from 1010 to 1110, but instead from 1110 to 13.4. This matters because 1110 to 13.4 is the elevation change, guys. He thinks it's left if that is a 1'6" call out, and you will see the 13.4 elevation. It wasn't from 1010 to 1110, but instead from 1110 to 13.4. Look to the left if that 1'6" call out, and you will see the 13.4 elevation. That's also why they use the varies in there. So it is not. 1010 was an old number, right? 1010 was the old number. It's not. It's the revised 1110 that we're working from. 1110 right here. This is 1110. This is 13.4. That's the lobby area. The lobby area. Here's 1'6" right here. This is 1'6". So the deck was to come between here. This will all add up for you. Between here and make it over to here and enter at the lobby. Well, not enter, but it will be at the lobby height at that point of 13'4". Going back to his comments, which is somewhere over here. Nope. Back to his comments. We'll pause that. No, we won't. We'll get to it now. So there is the beam. On top of this beam, it looks like it's like some old mortar on top. They usually use like these little shear links on top of here to help integral the deck, make it integral with the deck. They come up and they loop over and they come down, up, loop over and down, all the way around. So if the deck was to pull, it would pull on this beam. Well, it's all integral like that. It would want to pull on it equally. Over here is where I talk about, yes, that they went down probably together. There's the drape up. There is this turned up. This is this fracture here. It follows this line here, which is where the cars were. And there's the flower pots that were connected back there. This presents as a huge tear out of concrete, which means that it was actually anchored pretty darn well, doesn't it? But nevertheless, the flower pots and everything else, as it pulled away from the structure, all the way to the flower pots, cracked the overhang, the cantilever at that point. They rotated over. When they rotated over, they cracked it thereabouts this line here, I believe. If it wasn't for the flower pots and the way they were done, this pulled back wall would probably look like this, leaning against there. But the flower pots weight, when it went down, made it look like two fractures. The jealous wall I talk about. The jealous wall is also, pause. Do you see the firemen here? Do you see the firemen looking over the wall, the policemen looking over the wall in the other videos? Oh, wait a minute. Wait a minute. They were looking over the wall right here, weren't they? Where is that wall? Where is the wall the policemen were looking over? It was here, wasn't it? The jealous wall wants attention. It's down in the dumps. Who put it there? Who put the jealous wall down there? The wall is gone. it's down in the dumps. Remember, this is early in the morning now. It's gone, but nevertheless, they just it's like they don't care. The evidence is just like not evidence. It's down in the dumps now. It did have a fracture in it. I can't talk about. I can't show the video. I guess I could talk about it, but if you look at the wall, it has a rotation happening in it from the flower pots here. It doesn't really matter. It's not much in there besides at one point. Going back to the commenter, I wrote him saying, "Look, your math's off. 1'6". It just comes out to 13.4. They also That's also why they use the varies. There is nothing to vary there. There's 1'6". The design says varies because it's a 1 foot step and a 1'6" step. So they want you to use the same design, but over here they want you to step up 1 foot. Okay, one when it was 11:10, I mean 10:10 and 11:10, as I showed you in other drawings. Just the 11:10 one, and then there's the other one that's 162 is not loading, is it? Let's try shrinking down. Hold on. And the 10:10. So there's 10:10, 11:10. So it varies because that was supposed to be 2'6". This is supposed to be 1 foot. But the intent was to have this as varies, meaning this is the varies. Height varies. The height varies. You understand? The design stays the same, but the height is what's variable there. So when you're making that beam, over here you would make it so it works out to be 1 foot, 2'6" in this drawing, and 1 foot on this in this section. 2'6" here, and once that changes, it still has a varies on it, doesn't it? We'll go over to the left. It still varies, and then we find, well, what's the varies? We've got 1'6" here. We have 1'6" here, and 1'6" here. 1'6" there. That's where it goes into the elevation change into the lobby area. Previous drawing, we have 1'6", 1 foot. So as you can see, the varies is no longer really a varies. It's just in the new drawings, which this is the old one. This is this is the old one. You did have some varies. And this one, it's 1'6", 1'6", 1'6" right here. Everything's damn 1'6". There is a different one right there. There's a 12'9" elevation there. A slight step up. This is that patio that goes right between it, and that's right where our drape, my bias M is. I believe this is M, right? You can correct me on that if I'm wrong on there. Again, I'm not going to do any breadcrumbs in here. I just want to just give you the data now. So Jamie, you're doing good. Now let's get to that. What people are calling H beams. After I finish off with this conversation over here, let's finish this up. So this is what I get in return for you guys that are supporting Greg. A couple people you supported it. Sorry for deleting a comment. I just think it's taking it off point, but let's get to it. He writes back, I don't understand your math comment. And then he writes this answer. 11:10 plus 1'6" equals 13.4. That's what I stated. Okay, that's what I stated. Let's do it this way, he says. 11:10 plus 2 inches equals 12 foot. 12 foot plus 1 foot equals 13 foot. 13 foot plus 4 inches equals 13'4". What the hell is that? That's 1 foot plus 2 inches equals 1 foot 2 inches 1 foot 2 inches plus 4 foot equals 1 foot 6 inches. Now you guys have to realize this person saying he's not a troll. My math seems to be very solid on this. What is this? What is this? Now I could be misinterpreting your comments by my statement, but my statement is correct and shown on the plans. At 29, 1 foot 6 change wasn't from the 10 foot 10 to 11 foot 10, but instead from 11.10 to 13 foot 4. That's the elevation change up. Look at the left of the 1 foot 6 and you will see that it's 13 foot 4. I stated that in my video. Let's go 29 seconds. We pull it up. We pause the video. Not change over to here. Change from that point out. This point out. This is your oh shit zone. From here, all the changes happened. The tributary areas changed. We see we go from 14 bars and 11 bars and the change plans to 14 bars and 11 bars and the old plans. Nothing changed. It was 14 and 11, 16 and 5. 14, 11, 16 and 5, 16 and 5, 14 and 4, and 11. So you see that he's calling me out at 29 seconds. Let's 29 minutes. Let's try to go back a little bit more. This side didn't change. Tom, this side didn't change. Tadahashi and everyone else, this side did not change over to here. Change from that point out. This point out. This is your oh shit zone. From here, all the changes happened. All right, we passed away at 29:11 again. So you can see that I am not. His selection of the moment of the time frames and all that, they don't even add up to be related to what he's doing here. And so this is why I just block people like this. Look, I'm trying to give you content. I can't be distracted by stupid comments. And then worse than that, the person tells me they're here to help me. If I have to learn math in this way, I'm going crazy. But this is gaslighting also, because he's saying that you come here and it's not even at 29 seconds, 29 minutes. I wrote forward quite a few seconds and went back quite a few seconds. But this is where it goes. You can block, and I wrote him, I said, I'm going to block you. You keep up the stupid math comments. This is what I said I'm going to block you about. This right here. It's 11 foot 10 plus 1. He says, here, let's try that. I don't understand your math comment. 11 foot 10 plus 1 foot 6 equals 13.4. He doesn't understand that. That's simple as that. 11 foot 10, that's the deck height, and 1 foot 6 elevation equals 13.4. Puts you at the elevation of inside the patio, the lobby height. And then he tells me, let's do it this way. 11.10 plus 2 inches equals 12 foot. 12 foot plus 1 foot. Really, guys? You got to be careful. You don't know on my side what I see. And then, number one, I watch your videos to help you out. So he's only here to watch my videos to help me out. Not because he already knows. So you come here like this. And you come over here bouts. And I come here. And I say block user. That's it. I don't need your help. Don't need your help. Send that help over to the other channels. Delete. Send that great help you got going on in this great math. It's wasted on me. You're wasting it on me. Go somewhere else with it. Pool deck. Linda, we'll get to that. I didn't even look at it yet. Good view. Okay, let's click on it real quick. Good view of the pool deck. Oh, I think I know what this one is. An urgent search and rescue operation. I think this is the water. She shows the water inside now. Let's see if I can fast scrub it. Well, this would be his view then. He saw that, and that's that drape there. and there's a drape in that capacity coming down this way also. So our butterfly met its equilibrium right about here, where it started slowing down its forces because it was already bottoming out, and it went that far, especially because it broke the construction joint there. Let's go back to the content now and wrap this up with the H beam. So, oh, wait a minute, the video was H beam. So now you understand that a little bit more. The jealous wall is gone. The cop, somebody pushed it over. They sort of cut short on that. There's part of the potting there. There's the lighting and reinforcement that might have been inside of it. There's the block wall right there. The rest of it right there. The cop didn't just walk up to the edge and start shooting there. He's shooting over the wall. And now so then that's how you get your secondary fracture. There's part of the wall right here. The planter box. Separation and all. Not much to learn there at this point. It's gone in this one. We talked about that one. Let's go to hopefully they zoom out for the H-beam. Yeah, cut the cord. That's right. Let's see if I can. No, I guess we don't get to the H-beam. Let's try this again. There it is over there. Here are the columns that it was attached to, I believe, here and front. Here it is off to the side a bit. So that little rocking action going on when this went down, it just pulverized it left and right. The stripping it, I believe. I don't think they dug. Let me put this clear. I don't think demolition did this. I think this is when the building collapsed. It did this to these columns, these column supports. Because if you pull on one, it would have torqued it and torn it apart, and it does. And mostly they just grab it and yank it over with the machinery. So this one has all these supports. I think in one of the videos we can see the top one of this right about here and here. Remember, this is connected via beam inside here. So when we get the pulling of the deck, I think the pulling of the deck is sort of laterally a little bit. Just a little bit, and then as the deck collapses, it takes a shift backwards. It moves it off the center line of this column. It moves the center line. This is where the two cars parked. Remember the car? I said it parks there, and there's two columns rather. I wish I had the other video. This isn't going to work out because there's another. There's the column here, and that's the column. And so now we see that if we're looking at the steel supporting of the column, you can see where the relationship to it is now, and there it is there. But there's part of the steel there too. So there was some shifting off of it, and some shifting off of it, and yet it was tied because this is very interesting. Tied to it. Yeah, I can't tell in this video. This looks like it was side mounted almost, and this one looks like it might have been bottom mounted, but it's gone. I wish we would have seen this being demoed. How did they take this? What was left here? Was there a pad on top of this? All this is the stuff that really mattered, and now it's gone. The stuff that really mattered, and now it's gone. But what's telling of this is it stayed together. So back here, when the collapse happened, it stayed together and it shifted. Or did it shift? Did they shove it with a damn machine and it knocked over in this position? That's a tough one for me. It's very tough. Over here we don't get I can't quite see the stirrups the steel on it to see if it's stripped down, but that's in relationship to that one. And it's not bent, it's not fractured. So it's like no shifting took place at that point. So no shifting. I'm trying to show you where no shifting took place, and then we can then start finding shifting because we know the building pulls inwards, how it stacks, and we don't know the very bottom floor where it was. although it was dropping from the bottom, as you remember I showed you, but that was more like a lateral this way collapsing, each column going that way, but not from the basement not from the basement on this one. It's still standing proud. I want to end the video with that one, but I want you to understand that this one we were talking about, again, here's that H-beam. That H-beam is connected to this guy right here. Our H-beam on the ground is connected to our M. M is over here. I'm off by one, sorry. Apologies. So it's connected indirectly across this here. So if we can get this to pull, that's what I was talking about, rotation. That's what I remember now. How much of this rotated at all when this came down? And we're looking at, I'm trying to find that standing column. This one. It's labeled. I don't know if that's 89 or whatever it is, but it's diagonal. It's diagonal. Is it that one? Is it this one? So we got 1, 2, 3. 1, 2, and 3. So straight back. Straight back. I don't know if I see rebar down there or not. You know, I wish I had better imagery. But this, we can put these back in place now before they destroyed them down to this point, ripped them all apart to this point. You think it's by accident they ripped all this stuff apart by it like this? It's grabbing at it with the machinery? I don't think so. I don't think the crew was in on it. They just said, tear it apart, get it, throw it on the truck, we don't care. I think that's the gist of that. Alright, I'm going to end this video with that. Hopefully you get the content that you get. That there's your H-beam that everybody keeps asking about, that H thing. Or, I'm sorry, I think Jemmy called it an H, somebody else called it a U. Because they see it, to them they present as a U. And Jemmy says, no, it's more like an H. I believe Jamie corrects him on that. You can see the dimensions of it, 34, 35, and 33, how they're interconnected. This is that serious low-bearing transfer beam that goes all the way up. All right. So that's what we got with that. I wanted to share one more point back there. Oh, right, I already did. The back wall. You guys keep talking about the cop video. Well, once you see that currently the back wall's gone, but that jealous wall had a buckling point right here where it talks about, where it shows that it rotated a bit, pushed out part of the block. And that's where that cop's looking over the wall. That the cars, that the perspective the person saw was more than likely, where is it? The car's going out of sight and then stopping, and then he thinks the pool deck is then collapsing secondarily because its pool deck still goes down a little deeper. I think it was all in one shot, the butterfly right here, and that was just a perception on his part. And again, butterfly here. We see, if you notice here, this is up, and then up here. Yes, we have a cars there, but that's part of the butterfly. That's part of his perception of what he perceives. And the car stopped. The deck still keeps going. He does not say, I feel the deck disappear from under me and I fall to the first floor. No, it stops at that point. Phone calls take place. Sinkhole is called out by the lady up top here. A couple other people. Sinkholes when they look out their windows. Sinkholes. A sinkhole, rather. They can't quite see the cars down here, but sinkhole. Not back to the building, but sinkhole. And then I think that's when the stresses already happened. The earthquake already happened because it pulled on that what I believe it pulled on the deck, pulled on the ledger via being connected, the whole deck being connected right here to the structure, rattle the building, so it's going to rattle all three of these. But by chance, I think it rattled M the most. So the drape would have been like in this capacity, more pulling down from this way. I think it rattled and rotated M the most. Look what happens when I rotate M. When I rotate, okay, so when I rotate, oh man, I can't rotate. It won't let me rotate. No. Okay, so much for that. If I rotate by pulling M this way, this pulls on all this decking here. It stresses it. Some of it breaks apart, but it also pushes into the decking here. So that pushes there. Oh, I can't get to it. I thought it was higher up. This rotates this one outwards, right? So if it's pulling, so that's a rotation outwards. This is a rotation back in. See if I can get that to work like that a little bit. I guess not. This is connected across here. So we've got this connection now, right? So nothing's for free. So if it's pulling more so on M, it's creating a pushing moment on that one, right? So it wants to buckle or not. I don't know what happens with this one, which the compression in here. If its rotation is here, this wants to push across here. This might want to go even this direct. Well, this might want to even flex at that point, like that. This piece. But if it could rotate, it would push this one laterally. It might try to rotate that one, or it might just shove all three of these just a little bit this direction. It might shove these two this direction a little bit, but the pulling on this drape, let's see that, down to here, down to the collapse zone area, pulling on it, this one here, and the deck pulling also. Remember, there's plenty of deck here, fabric and material pulling across this. And we have my bias M. So ultimately, I'm going to get here. I'm going to pull them out. Ultimately, I'm going to pull on this. Where I pull it out of the wall just a little bit. Because the reaction from here pulls the deck down, drapes it. And when I say pulls it down, it's not just a flat ladder or flat across the top. Here's the roof deck. It's not like that. Okay. It's not like that. It's more like this with the column right here. It's pulling more across it like that over to the deck. I'll do that. And then there's a column here going down, supporting it. It's pulling on that, and in turn, there's a floor in here. A floor in here that's also not for free, gets pulled on. And somewhere about here is that floor that possibly might collapse, and we see through the driveway on the other side, this floor. It gets a separation, but remember, this is not looking like that. This is looking more like this, a BMH, remember? That this is more, yeah, I can't rotate. Yeah, I don't have the right tool up. So it can't quite rotate. It can't quite rotate. So the column stays happy, perhaps, or maybe it's integral with the column, right? This is the BMH. These are BMHs, so these beams are poured together. So then we grab this one and we throw it away. Now we put this back on here and we put our BMH back together. Now there's our BMH right here. I'm sorry. Looks like it's more like this integral steel and integral there. So it just pulls down. It drapes this around here. Either it drapes it around, separating it, which leaves that kind of, could it leave this kind of on its own to try to hold itself. Now the column doesn't have the support of the deck there to help back it up. It could have pulled it out, the one part of the BMH, the bottom part, and I just show it over here now. And now this could create a buckling moment as the floor collapses here. This could give us our reverse vibration from inside outwards once you pull this part off. That could do it that way. This could also just been, I don't have it draping too much around here, but it could drape around there like punching around like everything else. But I have, if it does that, we have a intercepting BMH here across here. So that would want to drop this whole BMH here. It would drop it because this isn't a ceiling, mind you. So if this drapes and pulls down this BMH here, if it's able to break that connection, I mean, what's stronger, the deck's punching shear ability, or this BMH? I would have to argue the BMH is stronger because as it tries to drape around here, it's going to fracture all around this BMH. Let's say let's keep the fracture like that. It's going to want to rip down it, and then when it came across to here, to this one, this other part of this BMH, this is now bearing, holding the structure above, right? It's holding that bump out, or is it holding? Oh no, this is holding hmm, the patio, the patio area, not the because I think the bump out's here with the condos above them. So then the pool runs over to this patio area here with that BMH there, where the planters I think are supported on. So you got your planter boxes here; they're not just laying on the deck. So it runs over to there. But again, this is kind of strong right here. This isn't really iffy. This is not iffy in its design. So it's pulling on all of the draped, pulling on all of this together. It grabs this. I think it does a rotation, like I said. So I have this rotation going on, and that rotation pulls out M a little bit. Either it pulls it out through this way, or it's able to slide the deck off of here, sliding it off. So sliding off would be um, no. Would maybe look something like this. Or did the machinery slide this off? Where it just pulled off those little shear links. When I say little shear links, that's biasly stated. When it pulls itself off the top of the shear links here, the links for the deck, when they pour the deck. That's it's biasly stated. I don't have, I didn't see how they demoed that. If they took it apart archaeologically, we would be able to say, oh, look, the deck's off of it, and it's off it cleanly. Wow, it fractured on two sides to drop on each side. Once it breaks the shear links that it's on top of here, it just breaks it. We've got the deck fractures, you know, because the shear links also acts as a point of, I call it a control joint, because steel inside concrete is a control joint that you placed inside the concrete. Yes, it's used for tension, but once you try to fracture it, I use that same steel as I know where the dissection of the concrete is that's thinner now. The steel is not participating in keeping the concrete together at that point when you go to, say, break on it. It's going to fracture at the steel location at this point because it wasn't designed to be impacted as such. So it's like an internal hollow void, if you will. Even though it's solid, it's a hollow void in the concrete. So you can impact it thereabouts. So we have these shear links here. So the deck pulls on it. It can break, it can not for free as it pulls. Again, I'm a biased one because I see it in the video. It causes a reaction in this M, just enough to make the deck, the building rattle. And now it does that. It rattles the column. Rattling the column causes the floors to start collapsing. To rattle this column away at the near top of the structure. Those floors can't hold on, being a weaker psi at the connections. They break, and it's in this capacity that they break towards this direction, and they start pancaking down. And they finally become level at some point around the eighth floor, and then they just pancake in different direction. They rotate, and they become facing, um, falling more south hitting first, and then north hitting last, and pulling back from the back of the structure to the front till it pulls over the wall. This then gets pulled down from the bottom because it's buckling from the bottom, and the floors start pancaking from the bottom on this structure to the right, from the bottom up. So remember, when I pull this down, it's not for free. I'm pulling on this column. So if you see me pull on this, if it pulls on it, it's also pulling on this direction. So it pulls on that a bit, and then it pulls on that one a bit. It's not for free. I'm going to bring it over to here. It pulls on this nodule here. Right here. So if I were to pull this down, you can see it pulls away from that connection. That's where we get that whole front building rattling just a little bit. But this one pulls the most where it starts having the floors coming towards it. And then these guys are secondary, and then these finally break free also, causing that progressive collapse to the left. And then this one gets buckled from the bottom. This actually gets buckled from the bottom too. At one point, it starts, the bottom floors go. The top floor goes initially, but then the bottom floors start going. If you look at the video good enough, you'll see that reversal. And my cardboard model would have shown that, but I think I'm just at this point with you guys. All right, I hope this was helpful so you can start seeing what's going on. Remember, the witness did not state, "Oh, it pulled me. I fell off my feet when the pool deck went down. It knocked me off my feet. It pulled me over." No. So our deck stops. And that's when people were able to. So this already took place. Our deck stops. People are complaining. They start making phone calls, etc. And then we have them leaving the front of the structure. We have some floor fall down. It couldn't hold itself. And it couldn't hold itself in that hammock mode, however it was trying to make it through that steel. It fell down inside here. People still got out because it didn't collapse just yet. The video has a little break in it, and then she doesn't pick up again till after the collapse. She doesn't pick up her camera again till after the collapse, the video. So there you go. So now you see some steps. You can watch this video again to understand what's going on here. I'll add that this had a pulling effect also from here. and I'd probably stress this direction a little bit, and this one a little bit. So it's being pulled down towards the arrows. But this one is my major one. This is my major contributing one. This one, my M column, which I've always started about M. There's always been M. That's buckling. Okay, take care. Being pulled away and then buckling. Not buckling because of weight, but because of being repositioned. And you have to get across that BMA to reposition it. To reposition it. And this is on the first floor level, pretty darn stable. So I've got the drape, it's getting over to this deck, this ledger, this 1'6" change, the deck being tied into it. See the deck being tied into the ledger, into the 1'6" elevation change. It's being pulled down. I've got it separating like this, and separating. If I can rotate it, pulls this away. That could cause this to drop down. It could pull both of them ways. What I'm just trying to show you here, it could have done that where this steel was engaged so well that it did that. Now it could have dropped down a little bit, but that would have probably fractured it across this beam here, and it would have lost all its gas. So I've got to get the forces working from here. I've got to get them. I got to get them pulling into my drape area. To get this M to fail first. I got to get them across this BMH here though. This beam up top. Got to get them across. You got to get it across. And that's why I have the tugging here. Way out here. This would tug it and get me my transfer. If I try to come across the deck to do it, I get a fracture here in my mind. Visually, I get a fracture here happening where it doesn't make it over. But if I can get this one holding on so well because of the tributary area or the critical zone area. If I can get it holding on pretty good as this pulls and tugs, I can get a rotation here. I can get a fracture here, right about here in this beam. Well, let's put it back to the other one. It would be here. I can get a pulling here. I can get a fracture in this beam. The fracture pulling over towards the failed zone down here. I can get a fracture and rotation. This will fracture it right there. That would then get the pulling from here. That would then pull there. That would rotate this one inwards a little bit. That help it fail a little bit. So this would pull this one, rotate that one in, and that could also push our deck, internal deck, the 1'6", inwards. If this were to push inwards, if this could do that, if it could have that force, but it's got to be. I got to have that force happening. I can't have that force happening up in the air like that. It's got to be the rebar pushing and rotating in there. The pulling is what I can make happen. Pushing at the top deck level is very difficult to make happen because everything's falling down and away. So to have it now push is and to go across these BMHs to do the pushing, that's at the higher level, that's 11'10" up in the air, and yet the deck is falling away. You can see where that's just physically not the mechanisms. So pulling away, you can get there from here. Pulling away and down, you can get this stuff crippling itself, pulling away. Pulling away, fracturing here, pulling again, tugging on this one, and then we start getting our separation of our right here. Now we can get some stuff falling down. We can get a separation, which also pulls on this end. We can get that to fall down, but we can't get it to fall down like that, can we? We see what it presents what presents, it might present as that, and we see it there, and then it's ramped up like that. But in the parking garage video, it might present, it might be ghost, but it presents like this, as a flat piece of slab that fell down. That means we lost our integral connection and it dropped down. It could even be from a floor above, second floor above, third floor above rather, second floor. It happened to drop down, but it looks too thin for that. Ending the video, just giving you the how I need to get to over here. I need to get this one to fail. I need to do that not by pushing it, because it's 11 foot 10 in the air and the deck is pulling away. So how do I get a pushing action like that? Can't get it. I can get a pulling action. I got to get my tug on. I can get a tug on, but I got to be careful, because once it it's not going to cross this one. So to get across that one, I have to make this one fail first. I can make this one fail first. I can make this one fail first by it being rotated in, being broken here, broken at that point. Now pulling on this last part of the BMA outwards, rotating it outwards. That would have a torque action of pushing that one in just a little bit as it rotates outwards and down. That would also blow this BMH out over here, pushing this one out over here, and now we've got our three columns acting together. Okay, ending video.